Hi everyone, in this video we're going to solve some right triangles and look at some models. So let's get right to it. So from geometry class, we want to solve a couple of right triangles, which means find all the missing sides and all the missing angles. So I encourage you to pause the video like usual before you watch me do it, but let's get started. C is given to you right here as the 90-degree angle, so it's labeled as such in the picture. And then little a and little b are given to you. There's a convention that the capital always stands for an angle measurement, and a lowercase stands for the side opposite that angle. So little a being 15 means that it would be opposite big A. So why don't I go ahead and label an angle big A, and therefore it's the side opposite is little a, and then little b equals the last one, and big B equals that one. Now, A and B here are interchangeable, but I did keep them in this order so that they would be roughly to scale, relatively speaking. You'd have the 15 referring to the smaller one. Doesn't really matter. So at this point, what we want to know is the size of angle A, the size of angle B, and the length of side C. Your exact process might be a little bit different than mine, but that really lends you to doing it in any way you feel like it. I'm going to go ahead and find C first, just because I know I can apply the Pythagorean theorem to find that. So why don't I go ahead and, figure out what 15 squared plus 35 squared is. So that's 1450 apparently. Now 1450 is reducing that is definitely divisible by 25, and we'll go there. And then 58, and then 58 definitely divisible by 2, and that's 29. 29 is prime. So when you take over here the square root of 1450 to get C equals the square root of 25 times the square root of 58, which will equal 5 root 58 if you want to be exact about it. And then we can, of course, get the approximate of 37.08. 38.07 rather, just said that wrong. So those are our exact and our approximates. Depending upon the way you do the problem, you might get an approximate, you might get an exact. We do have a little bit of flexibility, a little bit of wiggle room there. I'm not going to go nuts about declaring exactly what you round to, so if you said 38.1, you're also in the clear. But if you do this, it's more work to do another operation. So with that said, we still need to find angle A and angle B. Again, your process might vary. I'm going to choose the tangent of angle A is equal to 15 over 35. And so that means I'm going to do the inverse tangent of 15 over 35 to get angle A. So I am in triangle mode, which means I'm going to be in degree mode. So inverse tangent 15 over 35 gets you 23 degrees. And then just for kicks, I'm going to do that with a calculator, 67 degrees. All right, now, for what it's worth, again, you may have chosen to find angle B with a calculator. You may have said that the tangent of B was equal to 35 over 15. What would have happened if you had done that? The inverse tangent of 35 over 15 magically gets us the same answer. So just keep that in mind. Your exact process might be a little bit different, but you should be coming up with the same answers. All right, so I'm going to let you finish parts B and C by yourself, and then see what you come up with. So for part B, you should have gotten somewhere around this. I labeled A and B where I chose to label them. Again, it's pretty arbitrary. In fact, in this particular instance, I chose poorly in that I labeled the smaller of the two with the bigger angle. It happens. Don't let yourself get hung up on it. But try to plan in advance if you can. But sometimes it happens, so don't worry about it too much. I chose to use the blue information, the given information, to find everything that I needed to find. So I used the sign to find little b, because little b is, you're always asking the question, what do you know and what do you want? In this particular case, I wanted little b, and I knew little c, and I knew big B. So the only way I could do that was with sine, and that would be the opposite over the hypotenuse, of course. Same thing with cosine, but again, your mileage may vary. How you accomplish that might be a little different from person to person, but you should get the same answer. For instance, once you get here, some of you might choose to do Pythagorean theorem to find the last. Again, don't get too hung up on processes as long as you're understanding what's happening. For the part C, yeah, you can't do this one. So if you set it up according to the problem, you get a leg of 3 and a hypotenuse of 1. Impossible. The hypotenuse has to be the longest side, and if you didn't pick up on that, perhaps you did something like setting up the cosine of A would be equivalent to the adjacent over the hypotenuse. And what you can try is again, we're in degree mode. Always thinking about that. If you try to do the inverse cosine of 3 over 1, you get it is undefined. That is because the domain of inverse cosine is the same as the range of cosine. And remember that cosine y equals cosine of x, remember, is this wave function with a maximum of 1 and a minimum of -2. Remember, that's the range. So the range of cosine is between -1 and +1. I just wrote an x, but clearly I didn't mean that. I meant a y. So the range of cosine is that. So therefore, the domain of its inverse, the domain of cosine -1, would be between 1 and 1 with the x values. So you can only insert values between 1 and -1. 3 clearly being outside of the domain is undefined and geometrically supported with the fact that a leg cannot be longer than the hypotenuse. So with that said, focus more on these couple of them, but it was definitely worth mentioning the domain and range arguments. So with that said, why don't you go ahead and try a couple of word problems, see how you make it, and I'll be back in a minute with some things to talk about.